Good evening. Good evening and welcome to tonight's webinar. Just before we start, I'd like a very quick test. If somebody in the chat can just confirm they can see and hear me correctly, then we'll carry on. So a quick check. Am I making it through? Is everything working? Thank you, Guy. Picture and sound good. Paul, all good. Excellent, good. The IT was a little bit of a nightmare tonight, but, but we got there. Wonderful, thank you for joining. We've had about 50 people accept the invite for tonight. I'm seeing, where are we, 16 people at the moment, but that may grow as we go on through the evening. So thank you for joining, giving up your Saturday night, but tonight is one of our regular webinars to help students out on the courses. Some have possibly been to one of these before, some maybe not so. So what I'd just quickly like to do in the chat, if I could, is get you to type in the group that you're on. So we have course numbers. I think I invited people from 154 to 159, and we have a course starting tomorrow, which is course 160. So if you just type in the course that you're on, just the numbers 158, 159, 160, whatever it is, just so I've got a bit of a feel for who's on this evening. So type away. David Eaton, 159, Paul, 159, John, 168. We're only up to 160, so Steve starting tomorrow, Kev starting tomorrow, Tuna, 159, Drew, Andy, 159. That's great. Union starts tomorrow. Absolutely perfect. That's great. Okay, and Tony, nice to have you on. Thank you very much. And Tony's passed. You probably don't want to be on the foundation training session if you're already at intermediate, but nonetheless, you're very welcome. That's absolutely fine. Perfect. Okay, lazy one at 160. So good mix. I would just warn those that are starting with us tomorrow. A lot of this may not make sense yet. What we're going to do, I'll explain the process in a minute, but because we've got people on at various points, so people on course 158 and 159 have just finished, and obviously 160 starting tomorrow. So we're here really to help those that are on a course or at the end of a course to just help them pass. So those that are starting tomorrow, a lot of this won't make a lot of sense, might be useful background, but don't worry too much if none of this makes any sense at this point. The course will steer you through it. So for those that haven't been on one of these tonight, we split this up into 4 sections. The first section, I answer any questions about the course. So that will be useful for those starting tomorrow who don't know what to expect yet. So that's the bit for you guys, is any questions about the course, what to expect, how it works, when stuff gets delivered, how it gets delivered, all that kind of stuff. So we do section 1 first on the course. Section 2, we talk about the exams, how to book an exam, how to take an exam, what happens during an exam, any questions you've got on that topic. Section 3 is the syllabus. So those on the course know that we're in 9 sections. So we go through each of those one by one, and you can ask any questions on anything that's come up on the modules. And at the end, section 4 is other. So that's just a bit of a free-for-all really. Anything you want to know about amateur radio, anything that we haven't covered in the course, that sort of thing. So that's the plan. Some of you have been kind enough to send me in some questions. So I will be reading those out as we go. But the other 2 other quick house rules. One is if you have a question about your individual account, probably best to email me. We've had this before where people have said, oh, I've logged on my account, or can you read this email or whatever. Because we've now got 27 people on, I don't particularly want to hold everybody up by just looking at individual people's questions about their email addresses and things. So it's only sort of general stuff to help the group. Anything sort of private you need to talk to one-to-one, drop me an email through the through the normal course email. That's absolutely fine. And the other one is if we can try and keep to the sections. So rather than just sort of randomly throwing in questions, if we can try and keep it to the sections that they're in, just means it's a bit easier to keep control and make sure we do them all. So I will be doing technical basics, ask you questions now, stop. Let's move on to transmitters and receivers, stop. So if you can, try and keep your questions in the modules. That just means we're not dotting and darting all over the place. So are we all good? Let's just see if there's anything in the chat I need to worry about. John starts tomorrow. Faith in your skills as teachers. Oh dear, I wouldn't go that far. That's a worry. Yeah, okie dokie, that all looks good. Superb. Okay, so what we'll do first of all, and really apart from the questions that you've pre-sent, I'm going to be led by you guys on the chat there, so when I give you the nod, just fire in with your questions. So let's start with questions about the course. So what to expect on the course, how it works, any problems you've had signing up, anything you want to know about how our course runs. So let me take those questions from you first of all, please. Type away in the chat. I'll address those and then we'll move on to the next section. So anyone got any questions about our course or what to expect? Okay, not immediately seeing any questions. There's a bit of a lag on this connection. Looking at the screen, it's about 15 to 20 seconds worth of lag. So I will try and bear that in mind when I'm getting your questions. Okay, no questions on the course. That's fine. That's absolutely fine. I can always ask them again later in the webinar when we get to the end if you do have any other questions. But let's now take questions about the exam. Have I had any in advance? I've had one from, so start typing, specific, oh hang on, no, got one on the course. How long will the course be open as I'm falling behind due to ill health? So we released the last module after the 3rd week, and we tend to leave the course open for between 6 and 8 weeks after that. If for any reason you need it any longer, you're welcome to either re-enroll, or we do have all the videos up on the website. So normally 6 to 8 weeks. Can we request the next module early if we complete it sooner? So the way we structure it is it's a 3-week course, and because it's 9 modules, we do 3 a week, and we release them roughly every couple of days. So tomorrow you'll get module 1, Tuesday you'll get module 2, Thursday you'll get module 3, and so on. There is a timetable in the course. For those that are in a rush, want everything quicker, don't want to do it over the 3 weeks, we do have something called Fast Track, where we give you all the material in one go, so you don't go through the 3-week approach. We tend to find people don't pass as well on Fast Track, so the pass mark is slightly down with people that rush through the course on Fast Track. The 3 weeks seems to be staged well enough to let people sort of study 2 or 3 hours a week and prep for the exam. But if you are in a rush, we do offer Fast Track. We do ask for donations for Fast Track because it's a bit more admin to run it. But yep, Joe, if you're in a hurry, certainly Fast Track. If not, if you've got things like the manual, you can always study ahead of the next module if you want to. Yeah, normal course, 3 weeks, 3 modules per week. Okay, perfect. So let's talk about exam questions. Any questions you've got on the exam, you probably know you've got 2 options. You can go to a local club and take your exam, or take the exam online, invigilated over webcam. So any exam questions, I've had one in advance from Phil, who's having trouble logging into TestReach. So I don't know if you're on, Phil. If you are, I might need a little bit more info. But for those that don't know, TestReach is the platform that's used by the RSGB for the exams. If you can't log on because you haven't been sent a password, you just need to wait. So when you book your RSGB exam, about a week before the exam, you have a call with the invigilator and they send out a special username and password. If you're trying to log on now and you haven't been sent that username and password, you won't be able to log on, so don't worry. If you have been sent that password and it isn't working, then you need to talk to the RSGB. If they've sent you a duff link, you do need to talk to the RSGB to get that done. So don't know if you're on there, Phil, but if you are, yeah, if you've not got the link yet from the RSGB, it will be an email from the exams team at the RSGB about a week before. Look out for that email. If the code is in the email and doesn't work, then you need to talk to the RSGB. If you haven't got the email, again, talk to the RSGB. If you're trying to be clever and be early and beat the RSGB's email, you won't be able to log on because they won't have sent you the unique password yet. Hopefully that helps. Yep, so you've not seen it yet. You haven't been sent the username and password, so you can't log on because you haven't been sent the username and password. Right, other questions. That was the only question I had on exams. Do I need a separate cam for my laptop for the exam? So if you're taking the exam at home, you'll be invigilated over a webcam. Basically, the examiner will be watching you throughout the 1 hour session on the exam to make sure you don't cheat. They will need to use the webcam to do a basic sort of look around the room, just to make sure you haven't got the answers written on the wall charts or anything like that, that there's nobody else in the room with you. So you need a webcam that you can move about. You just need the one webcam. Absolutely fine if you've got a webcam like this one with a camera at the top, or a portable webcam that you can move about. You just need the one webcam, but it does need to be movable so they can check the floor, the ceiling, the doors to make sure there's nobody else in the room. So just the one webcam built into your laptop is fine. Otherwise, 10 quid, 15 quid, USB one, equally fine. Okay. Anything else on exams? Any other questions on the structure of the exams? While people are typing questions, you'll notice I normally have a quick slurp of the old cup of tea. Quiet bunch tonight. I'm normally inundated with questions about exams, but you're all good on that one. That's absolutely fine. Okay, if there's no more questions on exams, then we can dive into the syllabus. Right, John has asked, can we take the exam on the iPad? No, is the answer to that one. So the exam has to be taken on a Windows OS machine or a Mac OS machine. So anything that can run Windows or Mac, I can't remember off the top of my head the version numbers, is Windows 7 or higher, and Mac 18 dot something, 18.1 are the only platforms. So you can't take it on a smartphone, you can't take it on an iPad, you can't take it on Linux, you can't take it on a Chromebook, so it has to be Windows or Mac OS. If you don't have access to one of those, obviously you can take the exam anywhere you like, so go around to a friend or family member's house that's got one of those computers. If you really don't have access to any kind of computer and all you've got is a smartphone or a tablet, then you've got an option to go to a local club and take the exam there if you don't have access to a PC or a Mac. Okay, any other questions on exams? If not, we'll move on to syllabus. Syllabus, we're going to do this in sections. So we've got technical basics, transmitters, receivers, feeders, antennas, propagation, license conditions, EMC, safety, and operating procedures. I do have a question, just looking at the clock. Who was it asked? Philip, if you're on, asked FM repeaters. Using FM repeaters, how often is it used? How is it done? Philip, if you're on, just let me know. Local library might be a problem because for the exam you're meant to be sort of on your own and quiet. I don't think you can sit and take the exam in a busy library, but I do take the point. Philip, if you're on, let me know. The reason I ask is Philip was asking about repeaters and nets. There is actually a net running on my local repeater tonight. If you want me to do a little bit of live interaction, I'm quite happy to jump onto the net in, 15-20 minutes or something like that, just for 5-10 minutes, let you hear a net and we can take part in the net if you like. Up to you, let me know if you're interested. If you'd rather dive into the syllabus stuff, fine, but if you want to take part in a live net, talking to a few people in Essex, we can see if we can sneakily do that one as well. So let me know in the chat, do you want a bit of live interaction on air or cracking on with the syllabus? Let me know, I'm happy to dive in. That'd be great, sounds great. Okay, two yeses. That'd be cool, don't fully understand repeater setup, net sounds fun. Great, okay, that's cool. Right, somebody has the job of reminding me when it gets to about 8:30, let me know and we will jump on to a net this evening and just let you hear what they sound like, basically. Right, so let us look at technical basics. So does anybody have any syllabus questions for me on technical basics? So that's circuit diagrams, Ohm's law, the power formulas, any of that kind of stuff. Any questions on technical basics? Didn't get sent any in advance, but if anyone's in the chat that wants to know anything about the technical basics section, let me know now, and happily take any questions that any of you may have. While you're typing, I'm just going to double check the net's definitely on, so bear with me a second.
M0PLG Beryl, M0LMRV. That sounds pretty well. I mean, getting it for free.
Yeah, just out of curiosity, I've tried to move the speaker nearer the mic. Could you hear a voice then coming out of the out of my little radio behind me? If so, will be good. I tried to get the speaker as loud and as near as I can. Could you hear that? Just so I know. Great. That's encouraging. Lovely. Excellent. Loud and clear. Great. I was trying to move microphones around. I was trying to get this little mic of mine, little portable lavalier mic nearer, but I've had to move the speakers nearer to the main mic that I'm on tonight. But it should work. That's fine. Good stuff. Right. Technical basics. No questions by the looks of it. That's fair enough. More time to play radio and answer questions later. Quick query, can you transmit on HF frequencies with foundation? Yes, absolutely you can. Yes, you can. Okay, nothing on technical basics, that's fine. So let's look at transmitters and receivers. Actually one question in advance from David, who I think is on with us tonight. So hello David, good evening to you. Asking about sidebands. So he's actually mentioning a particular part of the book, which is I don't know how well you can see this on here, but in the foundation manual from the RSGB there are two figures, so figure 1 and figure 2. This will be the sidebands. So a normal AM signal will have an upper and a lower sideband and the carrier in the middle, and then an individual sideband at the top. David's question caught me out because I haven't actually read this closely enough, but he's asking about the width of the band, or yeah, so the bandwidth specifically, and why example 1 has a bandwidth that is smaller than the other bandwidth. Short answer, well, there's two answers to that. I'll give you the easy answer and the not so easy answer. So the easy answer is it doesn't matter for what you're doing for foundation. So for foundation, all you need to know about sidebands are the following 3 points, which is straight out of the syllabus. So point 1 is recall that when radio frequencies are modulated with an audio frequency, the new frequencies that are generated are called sidebands. Part 2, recall that AM signals contain 2 sidebands and 1 carrier, and that an SSB modulated signal contains only 1 sideband. So that's all you need to know. Worrying about the bandwidth and whatever doesn't matter for this. I think they've just used that as an example because that was probably stock image from somewhere else, and he's used 2 because it divides, or was it 4? 4 because it divides nicely into 2. But you can have different bandwidths for signal. So narrow bands, I think they just happened to randomly pick 2, but the actual value of the bandwidth as far as sidebands is concerned doesn't make any difference. Apologies to those starting tomorrow who might just be thinking, oh my god, this is all complicated. Don't worry, it will make sense as you progress through the module. So David, hope that one helps you. If you're still unclear, let me know in the chat. Otherwise, hopefully that has addressed that one. DX Commander does a nice video on Ohm's law. Yeah, wicked, brilliant. Could you please repeat the 3 answers? Yeah, okay. Just for information on this video, you do have the option just to rewind, but I will go through those again. So for sidebands, there's 3 things that you need to know. You need to recall that when radio frequencies are modulated with an audio frequency. The new frequencies that are generated are called sidebands. Recall that AM signals contain 2 sidebands and a carrier. So there you go, there's your 2 sidebands with the carrier. And an SSB signal contains just 1 sideband. So I hope that makes sense. We do cover it in the video as well. Watch back on the course video if you need it. Okay, no worries. Looks like you're all good on that. Any other questions on transmitters and receivers? So with that, we've got box diagrams, AM and FM modulation, and that kind of stuff. Any other questions? If not, we'll move on to feeders and antennas. If you're watching, Julian, thank you very much. My cunning little watch tells me that you've just made a donation for tonight. Thank you so much. That does donations do help us out. And what I'll do, Julian, with everyone that donates, I send out some extra mocks. So if that's useful, either later tonight or tomorrow morning, I'll ping you some mocks. But thank you very much. Right, Union, thank you. Lovely. Okay. So nothing else on transmitters and receivers. You're very quiet tonight. Normally I'm swamped with questions. Don't be shy. I am here to help. But we'll move on to feeders and antennas. And there will be some catch-up time later. If there's anything that you want me to go over again, that's fine. Feeders and antennas, I had 3 questions in advance. 2 from Graham, so I'll talk about those. He just sent me the one word, which is balun. So I don't know if you just want a sort of a general chat about a balun. You also tied it with a question about end-fed wire antennas. So I'm going to kind of lump the 2 in together. So let's do the technical explanation of a balun. So you will hopefully be familiar with the dipole type of antenna. That's the diagram for it. Some of you, if you're as old as I am, might remember old hi-fis used to have these things on the top hanging out of the back of the hi-fi. So that effectively is a balun, not a great one, but so the idea of a balun with twin feed ladder line. So that is an old school FM. It's a receive only, not a transmit, but that's an example of a balun. So you can see you've got 2 equal halves, and it's balanced because they're 2 equal halves. If you wanted to connect that to coax, so again there's my balun. If I wanted to connect it to coax, you see I've got a coax connector on there, where I just screw my coax cable in. Because the coax cable is unbalanced, so your unbalanced coax into your balanced antenna, you would put a balun in the middle. So balanced to unbalanced, B-A-L-U-N. So the balun connects unbalanced coax into a balanced antenna system. For a long wire system, so I actually quite like long wires, A because they're cheap, and B because they're actually pretty flexible. So here's my portable one. It's just literally a random length of wire wrapped around one of these little things, so I could just run that to wherever I want if I'm out in the field. Now if I want to link this to a piece of coax, again this is obviously unbalanced, and I'm going into unbalanced coax. What I would use for that is what's called an unun, which is, it's not actually a part of the foundation exam, so you don't need to know this at foundation, but it is like a balun, but it's an unbalanced to unbalanced. So effectively I put my coax there off to my transmitter, and here the active part of the antenna I would literally just screw in to that connector at the top there. If I want to use counterpoises, the ground planes, see the green dot meaning earth, I would run that off to my earth connector point, if that makes any sense. So that is basically a balun. It's not actually this one's a balun, genuinely a balun, but they look exactly the same. So that would be where you put one half of the wire going that way and one half of the wire going that way, and the connection to unbalanced there. And long wire, yeah, any random length bit of wire would do the job. So hopefully that one helps. Let's see if that answers Graham's question. So Graham, if you're on, if that doesn't answer your question, shout. How does tuning an antenna work, and would I have to retune for each frequency? Okay, let me just show you an ATU. I'm going to do as much sort of live, practical demonstrations as I can. Okay, so I've got a couple of ATUs. This is my portable one that I use when I'm out and about in the field. And literally you plug the antenna into one half, the feeder for the transmitter in the other, power supply into it. And on the front, I've basically got a tune button. When I press the tune button, it goes into tuning mode, and it will give me either a green or an amber or a red, depending on the SWR. And what's basically happening is this is a match. It's giving a match to the transmitter so that it doesn't upset the transmitter. So if I put 10 watts out of my radio, this will absorb those 10 watts and put it out the other end. If you were to look inside, there's capacitors and tuned circuits in here. And basically when you press the button, it scrolls through a bunch of options. And quite simply, you put a signal in. If it's 3 to 1, it's too high. So it'll try a different combination, and it will just click through various presets, find the best one, return to it, lock you in, and you're done. Yes, if you change frequencies, you would retune. So certainly with a long wire, every time I change frequencies, for instance, not necessarily frequencies, it's more bands. So if I was on 14.1 and I changed to 14.15, I probably wouldn't need to retune. If I suddenly changed to 7 meters, 7 meg, instead of 14 meg, which is a completely different band, then I'd press the tune button. So it's not for every little tiny frequency on the band, it is between bands basically. Hopefully that makes sense. Again, if I'm going too quick or making no sense, please do shout. In the course, why is a dipole described as half wave and the two verticals quarter wave and half wave vertical? Okay, I'll come on to that in a second, because Calder asked me a question about going through the different types of antenna. So if I may, I'll lump that all into one question, just for the sake of it. You mentioned the hi-fi is a receiving antenna. What is the difference from a receiving and transmitting antenna? Okay, may have slightly misled you on that one. So this one is for a home hi-fi. So it's designed for 88 to 108 megahertz, which is the VHF broadcast radio band. It's cut to exactly that length. If I put an amateur radio signal into it, it wouldn't be great, because it's not designed for amateur radio frequencies. Potentially as well, the wire is actually quite thin in these. If I were to put, let's say, 400 watts into it, the wire might melt. Yeah, the difference is kind of the quality in the wiring, basically. This is very cheap, thin, NAF quality wire. Fine for receive, but yeah, if I put 400 watts through that, it would melt, which is not good. But it's also cut for receiving BBC radio stations, not amateur radio signals. John is getting sound problems. Anyone else getting sound problems? Just keen to check whether it's John or me that's generating the sound problems. Anyone get any problems with the sound? Let me know. So Gary's okay with the dipole. Dipole half wave, could you have a longer one? Yeah, again, I'll cover that in a sec altogether, if I may. Is a separate unit better than an internal? Doesn't necessarily make any difference, really. No real difference. Convenience. I mean, I have a separate. I've got 3 radios and 1 ATU, so that does me for everything. I believe the one behind me on my main rig is probably better quality than the ones built into radios, so it's a little bit of convenience, really, I suppose. Where is the AMU placed in the sequence? Okay, yeah, happily take that one. So we have our transmitter. That's our transmitter, and our antenna. and you would have the ATU or AMU. In amateur radio we call them ATUs, but in the exam they're AMUs, antenna matching unit. So out of the transmitter into the AMU into the antenna. And you can see again on the back you've got an antenna. I don't know how well you can see that. ANT and TX. You literally connect from the transmitter into the transmitter socket, and then from the antenna to the antenna. So it sits between the transmitter and the antenna. Right. Okay, Joe's got the sound okay. Fine, it's not our end. That's all good. Right. Okay. So let's talk about the antenna types. So there's a few of you asked about this. So for foundation, you need to know about 3 types of antenna. You need to know about the Yagi beam antenna, the quarter wave, the 5/8 wave, the long wire or end fed, and the dipole. So they are the ones that you need to know about. So I've given you an example of a dipole. So that is a dipole, or that is a dipole. They are quite common in some circumstances, mostly for HF, to be fair. If you can get away with a dipole, they are absolutely brilliant. There was mention of half wave and full wave, which I will talk about. So let me just show you. So that would be a dipole, and if you were to measure end to end, like that, so from that point to that point, that would normally be half a wavelength. So a half wave dipole is quite common, and there's a reason why it is half wave, which I will explain to you. So, and this is now where we go back to our AM and FM modulation. So if we look at a modulated radio signal, which I've drawn pretty badly, but you'll hopefully be familiar with that. So that is an audio combined with RF radio signal. Now, under normal circumstances, so if we were doing, let's say we're operating on 14 megahertz, then that is happening 14 million times a second. That is going up there. Now this bit here, that half of the signal there, is exactly the same as that half of a signal there. So with a half wave antenna, you can get all of the signal. So a full wave antenna would get twice the signal. It would get the top half and the bottom half. So a half wave is optimal to get all of the signal. So that's typically why we would use a half wave. For 14 megahertz, if you use the comparison chart on the back of our friendly 4-page booklet here, 14 megahertz, if we went up here, would connect to 20 meters. So half wave would be 10 meters long. If you think the average car is about 3.5, so that would be 5 car lengths, or well, what, about 3 or 4 car lengths to get half of that waveform. So therefore 7 cars to get all of the waveform. So it's not practical. So a half wave would get absolutely all of the signal at half the length of a full wave, which means you can probably fit it in your garden, which is why we tend to use half wave. You can use a quarter wave. That doesn't get all of the signal. It will get a quarter of it, but because it's happening 14 million times a second, you only get half of it, but it's still 7 million to catch. So if I look at a half wave, sorry, quarter wave, might be something. Actually, I can't give you a very good example of it, but that would be sort of roughly the length of a quarter wave. So that's more. A quarter wave is more for VHF, UHF. Typically, it would be about 1 meter long. Internally, there's stuff that means it's not quite exactly a quarter wave, but again, there's so many different antenna types out there. All we're talking about at foundation is the 4. So you've got quarter wave. The diagram of quarter wave is, and again for the exam you need to be able to recognise these. So for quarter wave, it's a straight stick with two radial sticks coming off the bottom of it. Will be a quarter wave. 5/8 wave has a coil in it. I was actually cheating because that's got a coil in it there. It's actually a 5/8, but it was more for the visuals. If I show you a real 5/8, let's try that one. So this is a mag mount that you'd stick on top of a metal tray or something like that. Let's get that in there. So there we go, that is a 5/8, and you recognise it by the coil in the middle there. So the difference between the two, that one, our quarter wave, you would typically stick up on the top of your roof of your house, as high as you can get it. The reason for that is the signal is going to radiate in all different directions. So it'll go forward, back, left, right. So on the top of your roof, you want your signal, your VHF and UHF signal, to go as far as possible. So you have a white stick which goes out in all directions. It's called a collinear quarter wave, or they can be half wave, and again we've explained why half wave kind of matters. Half wave doubles the height on your roof, which can be a problem for neighbours and things like that. So you want a quarter wave on your roof to get your signal as far as possible. In a vehicle, you would more commonly use a 5/8, which has the coil. It's actually the same length, it's just shortened because it's wound up into a coil. The reason you use that is stick it on the roof of your car, and what you're trying to do in the car is push your signal out to the horizon rather than sort of up in the air. You don't want to waste energy going up, so you want all the energy to go out as flat as possible, following the typically metal surface of the car. So that loading coil shortens the length, so you don't bang your antenna into car parks and whatever, but it's also helping to push it to the lower part of the antenna to go for the horizon and use the metal of the car, which is why they're better. Long wires are probably the worst because it's just a random length of wire, not cut to the right frequency, normally hanging off a tree or out of a window or something, so they're not particularly great. And then the dipole we've talked about is kind of, you know, the very common standard antenna for HF use. So I'm hoping that's kind of rolled all of those questions about what is a suitable antenna for a certain situation, half waves, quarter waves, and all the rest of it. If that isn't clear, shout, but I'm hoping I've done that a little bit of justice and that all makes sense. I'm just going to go back through the chat and just see what I've missed. Okay, Paul, I've got your question on gain and multiplier. I will talk about that in a second. I just want to make sure I've not missed anything. Quad band antenna. Yeah, any antenna. So a dual band antenna is typically for 2 meters and 70 sems. Quad band will do 4 different bands. Ideal world, 1 antenna for every band. But for foundation, that would mean 14 different antennas. It's not practical to put 14 antennas up in most houses. That would be ideal and optimal, but who's got room for 14 antennas in their house? So we compromise. Here I have only 2 antennas. I've got an HF antenna for all bands with an ATU in it, and a dual band 270 up on the roof. Quad bands are great, they do work. They're always a tiny bit of a compromise, because obviously they can work on 1 of 4 different frequencies. So a little bit of a compromise, but you know, have you really got room for 4 different vertical antennas on the roof, and then 4 bits of coax running through 4 holes in the wall into your shack? Probably not. So good compromise. The 4 there. Dipole understood. Bit of lag. AMU makes the best of whatever antenna you have. Yeah, they're not miracle workers, so they'll only go so far. It will generally, I mean, this little portable one is not quite as good as my main station one behind me, but it tunes most things. It really struggles on the very, very, very low frequencies, so the 80 meter band. This just doesn't do a very good job of it, but it will do everything else, everything I need it to do. 40 meters, 20 meters, 15, 12, 10, perfect. You put anything you like in, a bit of wet string, coat hanger, whatever, it will make it work without blowing up the transmitter. Again, just to be clear, it's not a miracle worker in that it won't make your antenna better. So if you've got a really bad antenna, that won't make it better. What it will do is make it less dangerous. What you don't want is the standing waves coming back into the transmitter and blowing it up. So it's just creating a match. It's not going to turn a bad antenna into a good one. It will just turn a bad antenna into one that doesn't blow up your radio, basically, if that makes sense. Would a 5/8 wave CB thunder pole work with HF? So that's 11 metres. So it wouldn't be a perfect match. So it's close to 10 metres. Some of those antennas have a little Allen key that you can adjust it. If you can adjust it to 10 metres, great. And again, any antenna you want will work as long as the SWR is correct. So what you need is one of these. So that is an SWR meter that we talk about in the course. You plug your transmitter into one, your antenna into the other. Feed something like a watt into it. Don't put too much power in, just put 1 watt into it and see what the VSWR is like. So if you've got an old CB antenna, try it. It might work. It's close to 10 metres. Slightly altering the length of the antenna might get it perfect for 10. It's probably going to be dreadful for 40, but that's where you put an AMU in the middle. Hope that one helps. If we have limited space, is a vertical as good as a wire dipole? Again, very much depends. So again, we're probably talking HF, so around the world. And the easy way to look at it is, so you know, here's my house. That's a terrible house, but never mind. There's my house. Now, if you imagine the ionosphere above my house, if I want to talk around the world, basically I don't want any of my energy to go that way. I'm after getting the angle of reflection. So if I had a vertical antenna, then effectively the energy is going to mostly go that way, so hit the ionosphere at that sort of angle. If I had a horizontal antenna or a dipole, let's say I've got a dipole, let's just do a dipole for the sake of it. Now here I'm throwing my energy up in these directions, which means it stands a slightly better chance of bouncing off the ionosphere. So a lot of people prefer horizontal antennas to get as much energy up in the air and bouncing off the ionosphere. With a vertical, the angle of attack that you're hitting the ionosphere will be different. They do still work, don't get me wrong, and it depends where you want to get to. But you know, you've got the choice of hitting an angle like that or hitting an angle like that. So it really is a little bit of luck and the angle. So you can try both. Some people swear by vertical, some people swear by horizontal. Apologies to those that have been on this before, but I always give the example of people that want a cheap HF antenna, and they don't want, either they're not allowed one where they live or the wife won't let them have one or whatever. Is an old trick that I was taught, which I have used, where you basically get a bit of equipment wire like that and you nail it into a tennis ball and you throw it over your roof. So if you've got a pitched roof on the top of your house like that, literally you throw a tennis ball over the top, the tennis ball ends up sitting in the gutter, and that you run into your radio and connect to your transmitter. And effectively what you've got is an upside down V, and the energy goes off in that sort of direction and nicely hits the ionosphere. And it's invisible, so your neighbours can't see you've got one, and obviously it's kind of like that, perfect degree to hit the ionosphere and bounce around the world. So people do use the old tennis ball and bit of wire trick to get a cheap and invisible antenna up on the roof. Okay. Oh, missed the net. No, we can. Oh, right, net. Yeah, let's do the net. Let's have a go. See if the net's still going on. Oh, we missed the net. No one reminded me. Hang on, I'm just going to see if anyone's on the net actually, just on the off chance. So the question was, how do we use a repeater? So I'm going to just try that now. This is Mike 0 Papa Sierra X-Ray listening through GB3DA. This is Mike 0 Papa Sierra X-Ray M0 PSX listening through GB3DA for a contact. Ah, we missed it! Right, hang on. I'm going to pull in a favour. Let me see if I can pull in a favour and get somebody on.
M0 PSX, M0 OTV.
Ah, cracking, there we go. M0 OTV, M0 PSX. Good evening to you. Andrew, how are you doing this evening?
Yes, not bad at all, Pete. I thought Bertie's net was on. It must have finished early. I was on for the first few overs and then I had to go and have me supper. And I was coming back. But I was sort of expecting that to still be going on.
M0 OTV, M0 PSX. Yeah, so was I. And funnily enough, we're not actually alone tonight. So looking across the other side of the room here, I was actually trying to dip into Dorothy's net tonight because I'm actually live on a training webinar at the moment with 34 people studying for foundation. And one student asked how repeaters work. So I thought I'll dip into Dorothy's net and do it. So you're now famous, Andrew. You're now talking to 34 people across the UK who are studying for their exams, and they're hearing every word you're saying. So I'll let you put out a shout out to the students on the foundation training course. So back to you, M0 OTV, M0 PSX.
M0 PSX, M0 OTV. Well, yes, congratulations everyone who's on the lesson.
Okay, yeah.
And yes, it's not very long since I was attending Pete's lessons, less than a year in fact. Yeah, congratulations. Hope you enjoyed it. I'll put it back to you, Pete. M0 PSX, M0 OTV.
M0 OTV, M0 PSX, yeah, cracking. Well, it's just checked in the chat room. People can hear you, so it's obviously all working. Yeah, so Andrew was a student on the course that you're all on at the moment, about a year or so ago, if you didn't catch that. So I'm just going to explain briefly about the etiquette of how this is working. So unlike the 2 meters calling frequency, you don't call CQ on a repeater. You heard what I did. I put out a call saying M0 PSX listening through GB3DA. Andrew heard me. You notice when I dekey and take my finger off the mic, there's a click. That's the repeater resetting so that somebody else can use it. We listen for that click and then we jump in. So hopefully that makes sense, guys. We probably overuse our call signs. You know the rules on call signs, but Andrew and I are being a little bit formal here because we're kind of used to doing it that way, where we give each other's call signs when we hand back. So there you go, dual commentary for the internet and for you there, Andrew. So I'll pass it back to you. M0 OTV from M0 PSX.
M0 PSX, M0 OTV. Well, I wasn't expecting that, I have to say. Yes. Yeah, it's great that you've got these courses running so regularly, and I'm sure you're doing a great deal to bring new people into the hobby, which I think is definitely required.
Anyone got any questions for Andrew?
Yes, indeed. Very fine thing that you're doing there. As we mentioned earlier, I did do your foundation course last year in April, end of April, beginning of May, I think. And I think during May, I sat my foundation exam, and then shortly after the intermediate exam, then finally the full exam, in a fairly short space of time. And yeah, it's been a lot of fun. So we'll be coming up on a year in amateur radio fairly soon. I received the other day from the US my DXCC paper certificate from the American Radio Relay League for confirmed contacts in over 100 countries.
M0ITV, M0PSX. Yeah, perfect. Thanks for the kind words. Check's in the post. Got some greetings for you here. So I've got hi Andrew from Nuneaton. That's from Joe. Hi from Union in Carlisle. Evening Andrew from a breezy Sheffield. Hi Steve, also in Sheffield. Many thanks from Central West Scotland. That's cool, from South East London. That was great, thank you. Good evening from Glasgow. Awesome, there we go. Okay, if it's okay Andrew, I'm going to be rude and jump back onto the training session, but just nice to do a live demo of how repeaters work. So really appreciate you coming up tonight, much appreciated. I was hoping to get Dorothy's net as well, but just missed it. But glad somebody came back and glad it was you. I guess we'll catch up on Monday for our net on a Monday night at 8. Cheers for now, thanks for the contact, and have a good evening. M0ITV, M0PSX.
M0PSX, M0ITV, that's great. Okay, thanks for the call, Peter. And thanks for the greetings from the students. And M0ITV going QRT, thank you.
Yep, cheers Andrew, thanks very much, have a good one, and catch you on Monday. Cheers for now. M0PSX off and clear. Ta-ra. Okay. Job done. There we go. Yeah, so Andrew, lovely guy, meets up with us now and again at some of the events we do in the south of the county. Yeah, he's a good guy. He's put me onto Meshtastic, if anyone's heard of that. I was chatting to somebody by email about Meshtastic, so he's all about that as IT networky stuff. Well, that was good, doing all three so quickly. Do you have to send Morse? No Morse at all. Did Andrew close by saying going QRP? QRT, in that case. QRT means going off air. So we remember it as quiet, QT, quiet. So yeah, QRT is basically switching off for the night. QRP is going low power. But no, QRT for Tango is a goodbye, effectively. Okie dokie, no props. You have a small setup. What's the transceiver you're using? I'm actually on, I'm not on my normal radio at the moment. That little one I've got is my first radio. It's a Yaesu FT7900, which was intended to go in the car, and I use it as a backup rig. My main rig is not well, so I'm actually on the backup rig at the moment, which is good. Bit of history, really. My old favourite, my old faithful. Right, okay, what do I got here? Martin says, my 13-year-old daughter is planning to do foundation. Is there a junior group? There isn't that we run. Our course is okay for youngsters, so if it's helpful, brilliant. What I would say is there's something called Alex Does Foundation, which is, comic book's the wrong word, but it's a young version of the manual. By a guy called John Hislop, who's brilliant. He's a really nice guy. He's done Alex Does Foundation, which is a sort of youngster-friendly version of all the training material. Freely available on his website. Alex Does Foundation is what you'll be looking for. We do link to it on our site, but that's probably the best way to go. The reason we don't do a youngsters group is we probably get 5-10 youngsters a year. It's not worth doing a solo course for such a small group. Sad but true, unfortunately, we don't get that many youngsters coming into the hobby, but Alex Does Foundation, definitely worth a look. Okie dokie, Meshtastic, yeah, that's all good fun. Right, so I'm just going to jump backwards. There was a question about DB conversion tables, so we'll briefly talk about that. And then we'll move on to propagation, which is our next topic. So antennas. Antennas usually have some kind of gain. The ones that have the most gain, of course, is the good old Yagi, which, very bad drawing of a Yagi, but like TV aerial is a good example of a Yagi antenna. So you've got the business end of it that does the work, and then these little elements that focus the energy off into one direction. So if an antenna has a gain, and again, some people do look at it and go, how can an antenna have a gain? You put 10 watts in, there's no amplifier, so how's it doubling the gain? Where's the power coming from? And for that explanation, I default to my friendly torch. So if I have a light bulb like that, you can see it shines in all directions. So it's putting out energy that way, that way, that way. So imagine that's our transmitter. Light waves and radio waves kind of behave the same, travelling in straight lines. So if that was our transmitter putting out 10 watts, then some of it's going that way, some of it's going that way, some of it's going up, some of it's going sideways, whatever. A Yagi antenna focuses it into a beam. So I'll now convert this into a Yagi. Now all of the energy is going into that. And you see that's a lot brighter than that, because all of that energy is being focused into a beam. You see nothing comes off the sides. So that is exactly what a Yagi is doing. It's not amplifying it, it's focusing it, which means all of that energy is concentrated in one direction. So that's what we mean by the gain. And the gain table, because it's logarithmic for those that understand such things, an antenna with a gain of what we call 3 dB would double the power. So if I were to put 10 watts into a 3 dB antenna, I'd actually have 20 watts coming out the other end. And at foundation, that's perfectly legal. So basically 3 dB on the table means times it by 2. 6 dB means times it by 4, so that would be 40 watts. 8 times 80 watts. A 10 dB gain antenna, which is huge by the way, would put out 10 times the amount of energy. And for foundation, that's measured into the antenna, not out of the radio. So if you did have a 6 dB gain antenna, as long as you put 10 watts in, which is the foundation limit-ish, long story, it would actually radiate 40, and that's perfectly allowable, with the exception of, hopefully you have got this if you've done module 6, some have an ERP limit. So that particular band has an ERP limit of 10 watts. So if our gain was 3 dB, it would mean we'd put 5 watts into it to get the 10 watts out. If we put 10 watts in, it'd be putting out 20, and 20 is greater than 10. Hopefully that makes sense. I did rush that a little bit, but hopefully that makes sense. Does that help on the dB multiplier, please? Are there junior radio groups and contacts? Yes, yeah, there are a few out there. There's various sort of build-a-thons and stuff. It really depends on which part of the country you're in as well. Up Liverpool way, there's a group called Quantum who do basically kids clubs. Other parts of the world don't tend to do a lot for kids, so have a look around, see what's on offer in your neck of the woods, see what your local clubs are up to. Occasionally there are events, things called build-a-thons are quite good, where youngsters sort of build radios and stuff like that. But it sounds horrible to say it, but the average amateur is between 35 and 65, mostly male. So we don't tend to attract the ladies into the hobby, and we don't tend to attract the youngsters into the hobby. It's disappointing, but unfortunately that's largely where we are. Is there an optimal coax length? Shorter the better, generally. Let's just briefly talk about coax. Yeah, I mean, having no coax is the best that you can hope for, so the shorter the better, really. The longer, the more loss you get. So this is an example of a bit of coax. This is RG58, which is what we typically use for HF, or RG213, which is a lot more sturdy. And you can see the size difference between the two. There's also a price difference as well. Or you can go up to something closer to something like Ultraflex. Again, you can, just for comparison, you can see the size difference there. The longer the coax, the more loss, so you're going to lose signal through it. If you have got a very long run to do, like you're looking at, I don't know, whatever, 10 meters, 20 meters of coax, you'd be better off trying to get as thick a cable as you can to keep the loss to a minimum, because it will just get dissipated out through the coax. So the shorter the better, generally. How much power can we put through RG3 316. No idea. I could Google it for you if you like. If you've got access to Google, that will have the specs for all the various different types of coax. If you don't have access to Google, let me know. I can Google it for you live. But lengths and loss, there are plenty of tables and websites that list it. But they're not numbers I know off the top of my head, unfortunately. But Google is your friend. If you, for some reason, can't find it on Google, let me know. I'll have a quick look for you. Same as Freemasonry, model engineering, the same. It's difficult. We've tried running events for kids in the past as a group, and it's a real struggle. I won't bore you too much with the details, but we had an air cadet group where we had 6 students trying to get their licence. In the end, only one of them passed because they struggled through the exam. That poor youngster didn't have anyone to talk to on air. He was chatting to 50-year-old blokes. They didn't really want to talk to him. He didn't really want to talk to them. None of his friends passed. He wanted to get into HF because he couldn't talk to anyone locally. And then he was told, the radios are about 500 quid and you'll need to put an antenna on the roof and drill holes through your house. And his parents didn't want to do it. So, he went through all that hassle of training and had absolutely nobody to talk to and couldn't get an antenna on his roof. So he left the hobby, which is a real shame. So it's difficult trying to get youngsters in. My approach now, rather than trying to get them in and then watch them get frustrated and leave, is show them what radio is all about. Show them things like Neshtastic networking or listening to radio or whatever, so that when they're a little bit older, they may want to take it up as a hobby, because trying to get them into it is a challenge. There are some youth clubs out there, and there's also the group called the RSGB Youth Committee. I think it was Martin asked. So look on the RSGB Youth site and you'll see some of the things that go on. Each year there's something called YOTA, Youngsters on the Air, which is an event for youngsters to get on air. So have a look at YOTA, Y-O-T-A. And in October there's a scouting event called JOTA, Jamboree on the Air, where scout groups get on air and talk to each other. So there are a couple to look out for: RSGB Youth, YOTA and JOTA. Hope that helps. Poor fella, he may come back. Yeah, I hope he will. I hope he will. He's a lovely guy, and it was a little bit of a shame, but yeah, there we go. Right, I think we're up to date with the questions. Just make sure I haven't missed any. Suitable antennas we've done. Balance wire fed ones we've done. If I've missed any questions, hold them. I'll ask you again at the end. I think I've got them all, but if I've missed anything, let me know. Right, next up, propagation. Anyone have any questions on propagation? So that's the ionosphere, line of sight, all that kind of stuff. Any propagation questions, please? Hoping you're loving all my props, cheap torches and bits of wire and stuff. It's all good. Not seeing any propagation questions, so that's fine. Keep them coming if you're still typing, don't worry about it, that's not a problem. We can move on to license conditions though next. So anyone have any license condition questions? Or actually I've got a propagation question, so I'll come back to licensing in a minute. But you get ready to type your licensing questions in. If VHF, UHF is line of sight, why only 100 watts of TX power? Is it 1,000 watts? I can't see as a character in the way. Why use... Oh, I see. If it's line of sight, why use that much power? Yeah, good question. We don't need it. So the new license condition rules give me a kilowatt of power. Don't need it. Don't need it. Rarely use over 100, if that. Normally it's 50 that I use. But hey, Ofcom's going to give us a kilowatt. We'll have a kilowatt. Yeah, it is. So broadcast radio stations will use more. They'll typically have a higher antenna point than an amateur can get, and they want the longest range possible. And FM radio receivers are quite good at coping with that. So, like your local BBC radio station might have a transmit power of a kilowatt up very high to cover the whole of the county. in which case you do need as much power as you can get. But for amateurs, 50 watts, perfectly adequate. The difference between 50 watts and 100 watts on a like rooftop antenna is very minimal. So yeah, we don't really need it. Right, okay, so let's look at license conditions. I had a question from David that says, when is it mandatory to use your signal and location? So let's take each one separately. When is it mandatory to use your call sign? The rules are a little bit odd. So the official rule is you need to use your call sign so that your station can be clearly identified, and you give your call sign as frequently as practicable, is the official Ofcom line, which doesn't mean a lot because it's practicable to use the call sign every 5 seconds. So you heard me on to Andrew earlier. The rule of thumb most of us follow is when you first go onto a frequency or you first start calling. So when you heard me on the repeater, the first thing I did, I listened to make sure it wasn't in use, and then I said, this is M0PSX listening through this repeater. So I clearly identified myself at the start of my transmission as this is who I am, and then I waited for somebody to come back to me. The person that came back said M0OTV, so he's identified him, so we now know who's talking to each other, and other people know who we are if they need to hear us. That's probably all we needed to do. We're used to, on a repeater, Andrew and I take part in regular nets where we might have 5 or 10 people on. If you have 5 or 10 people on, when you've finished, it's normally good discipline to identify who you're giving it to. Otherwise, if I had a chat and said, right, over to you guys, what do you think? Then 5 people would all transmit at the same time and overlap each other. So what I'd normally do is say, okay, I've finished M0PSX, over now to M0OTV. And that makes it clear it's gone from me to that next person. And at the end of his, he'll say, right, I'm M0OTV, now handing it to M0LMR. So it's kind of courtesy to a certain extent. Ofcom need to know who you are. If you're causing interference, they need to know the location and the name of the station. And amateurs use it as convenience. So the Ofcom rule as written is a bit weird, but an element of common sense kicks in. You know, if you were to be listening to somebody on the radio, within a reasonable time period, could you know who that person is? And if they hand over to you, is it clear that it's not them anymore, it's now somebody else? So it's a little bit informal, but that's the basics there. As for location, so without getting too complicated, the license conditions have recently changed. The exams that you're on, if you're taking your exam between now and September, you would need to be examined on the old license conditions. Ofcom announced in February that they don't care anymore about locations. So from now, legally, I don't need to give any kind of locational information at all. As far as the exam is concerned, you need to know 2 things. If you're transmitting in a different region, you may need to add the RSL, Regional Secondary Locator. So you might have a W, an M, an I, a U, a J, or a D in your call sign. So if you're taking the exam between now and September, you need to know these letters and where they sit in the call sign. So if I was transmitting from Wales, I'm MW0PSX. If I'm transmitting from Scotland, I'm MM0PSX. If I drive across the border from England to Scotland, as I cross the border, I'm calling out as M0PSX. Across the border, I'm then MWPSX. So it's the country that you are transmitting from determines the call sign. At the end, optionally, you can have /M, /P, or /A, which M is mobile. So if you're walking or on a boat or in a car, you're mobile. P is portable or temporary. That's if you're in a field in the middle of nowhere. /A is at an alternative address. So if you're in a hotel, for instance. So that is the locational information that you optionally need to give as far as the exam's concerned. So hopefully that is a long answer to David's question about call signs. So any questions on license conditions, call signs, anything else? License conditions is the biggest section. It's 6 marks of a 26 question exam. So Ofcom really do care about this section. That's why there's so many questions. And you will almost certainly need the exam booklet, because some of the answers will be in here. So get used to using the exam booklet for Module 6. Right, let's see if we've got any questions. When is it required to give you a call sign? Hopefully, David, we've done that. Also, when you're in a big group with lots of people, it's useful. Yep, done that. That's cool. Is it correct that the band plans are the gentleman's agreement not laid down by the authorities? Yes, absolutely correct. So I'll briefly touch on that. So in the 4-page exam booklet, that is what you should be familiar with. Page 2 lists the frequencies that we are allowed to use. So Ofcom have basically said you can have all of these frequency ranges and do what you want with them, within obviously the rules about power and whatever else. So for amateur radio use, let's take 144 to 146. Primary use for amateur radio, including satellites, up to 10 watts. So we can do what we want in there. But obviously it's ridiculous if we just had a free-for-all, we'd all be talking where we shouldn't. So this is decided by Ofcom. They decide how we use this. The band plan, so if we look at, again, 144 to 146, it's just that one sliver of a line there. Expand it out, that's what we have decided to use it for. So this is set by the RSGB. Yeah, gentleman's agreement is exactly summing that up correct. And what we normally say is the Morse code stuff goes at the top, the data stuff is here, the sort of digital stuff is here, the voice stuff is kind of down here, the repeater stuff is down here and a bit up here, and then the space stuff is down there. And we decide that. It's actually decided by a group that does it around the world. So we kind of coordinate with all the other countries. So if you go to another country, broadly there is some similarity. Similarly for the HF band, obviously it would be chaos if the UK did Morse here and Europe did the voice here. So there's coordination so that you know anywhere in the world, up the top of the band is Morse, down the bottom is going to be your voice, and the data in the middle kind of stuff. So it's by agreement within the amateur radio community so that we all know what we're doing and we don't transmit and upset other people. But now Ofcom, if I transmitted on the wrong frequency within this band, local radio amateurs might get upset, but Ofcom won't care, if that makes sense. Okie dokie, hope that answers that. Yep, lovely, that's great. I think I've answered all of those. So if there's nothing else on license conditions, I'll move on to EMC. So EMC is interference filtering. Anyone got any questions on that sort of topic, please? I'm just going to quickly check my emails while you're typing those. Just in case anyone's emailed me a question that I might have missed. Gary, donation. Thank you very much, sir. Much appreciated. David has got the link. Okay, yep, struggling to get into the link. That's fine. Gary managed to pass foundation this evening, first time round. Woohoo, well done, Gary. No, not missed anything. That's fine, great. Okay, cool. Do LED lights cause interference? Yes. I've got LED lighting that doesn't, but it can cause interference. Yeah, certainly. A lot of people do report that they do. I'm lucky. I've got LEDs, so I've got LED lighting around me and LED strip lighting up here and LED lighting all over the house. Doesn't personally cause me interference, but it does cause other people interference. I think maybe I'm just lucky. Okay. Nothing else on interference by the looks of it. So safety. Safety is the easy module. I'm really hoping that all of you will get the 3 safety questions right. It's all about not electrocuting yourself and falling off ladders and stuff. But if you do have any safety questions, fire away. Okay, nothing on safety, that's fine. So last of the modules is operating practices and procedures. So if you have any questions, type away please, and I'll happily take those questions. There's a question re headphones that caught me out. Yeah, there's some dangers with headphones that you need to be aware of. You never quite know the volumes that you're going to hear somebody at. Some people are quiet, some people are loud. We've all done it. We've turned our headphones up to hear a weak signal, and we're just getting that weak signal through, and then a loud station jumps in over the top of it and deafens you. So potential damage to hearing by using... Oh, Joseph. Thank you, Joseph. Donation. You're a star. Lovely. Much appreciated. If you're on tonight, hello, Joseph. Yeah, so do watch your hearing. You can damage your hearing through excessive listening of headphones, and it's cumulative as well, so it kind of builds up over time. The other common one is tripping over the leads or getting them tangled up in things. The number of times I've seen it on a field day where somebody's sitting there with their headphones around their neck, they get up, forget they're plugged in, and they pull a £5 radio off a table onto the floor, or tripped over the lead or got it caught up in a chair or something like that. So do just be a little bit cautious with headphones. Yeah, it nearly wrote off a £5,000 radio. Somebody just forgot they had them around their neck, stood up and yanked the radio off the table, pulling all the wires out the back. Was a bit of an argument over it. So yeah, just kind of be aware of those risks there. Reference as a trip hazard. Yeah, absolutely. Yeah, it gets tangled up in the chair. People will fall over it. Some people have very long headphone leads that can cause things to be tripped up. So just long trailing wires, pulling, standing up with headphones plugged in, just something to be aware of. Basically, it's sort of fairly common standard trip hazard type question. Oh, that was you. Thank you, Joe. Lovely, you star. Cheers for that. I'll send you some mocks later. Wouldn't most circuits have some sort of electromagnetic interference to the transceivers? Yes, this is LED lighting, isn't it? Yes, but people do tend to buy cheap. I'm guilty of this as well. Imports from China, where their standards aren't quite as rigorous maybe as the old CE standard used to be. So yeah, not all things are equal. There's other things that have caused interference before. Wi-Fi routers. There used to be a thing called power line adapters that you'd get your internet over mains wiring, and they basically turn your house into an HF transmitter. So if you had and I used them, I didn't have a problem with them. I bought expensive Netgear ones, and I'd have one downstairs, one upstairs, and it would just send the internet over the house wiring. Didn't have a problem with it. Other people that bought the very cheap ones off Amazon basically turned their house into a transmitter, and they couldn't get HF to work because they had a house full of it or their neighbour had one. It's all about how well these things are made, what standards they're made to. Some things can be really quite bad if they're poor immunity. Switch mode power supply. Cheap switch mode power supplies, if that means anything to anyone, that's the root of a lot of evil for a lot of people. Yeah, TP-Link, yeah, they're good as well, but the cheap and cheerful ones, not so good. Read the question carefully. Yeah, absolutely. So on operating procedures, type away if you've got any operating procedure questions. I had 2 in advance. One I'm hoping we've done. Philip said, FM repeaters first accessing, do you listen, ask if it's being used, listen for a tone or put your call out. So yeah, you do listen first. If it's not in use, you don't call CQ, you just announce that you're listening through the repeater. When you dekey, you hear that tone, which is the repeater setting. There isn't a tone on our repeater locally, you just heard the click or the crunch as it dekeyed. But hopefully we've done repeaters there. There is a video on repeater QSOs on the course as well if you need it. Andrew asked about beacons and how they are used. I just reminded me, somebody asked me a question. I can't remember if it's for tonight's webinar or not, but we will just briefly touch on that as well. 145 500, we'll mention that. Beacons and how they're used. So there's 2 different types of beacons. A common one is, and if you look it up on Google, GB3 VHF. And there's also GB3 UHF. They're based in Kent, and they literally beacon out their ident for you to tune into. So from anywhere you can try and receive GB3 VHF. And it's useful as a tool to see what your reception's like and how far out you can hear a signal. So basically a constant signal that you can tune into, like the equivalent of tuning into BBC Radio 4 or whatever. If you can tune in and hear it, then you know your car radio's working. So that's the principle. There are various beacons around the world that just transmit a tone or their identification or Morse or whatever. You know where they are, you point your antenna at them. And commonly, good example, so I can hear GB3 VHF here, quite weak. If I put up a new aerial and I want to test it, first thing I do is tune to GB3 VHF. If the signal's got stronger, well, hey. If the signal's got worse, I've done something wrong. Similarly, if you want to check your radio's working, if you think, I'm not sure my radio's working, you tune to a source that you know will be there. If it isn't, it's your radio probably. So that's largely what beacons are for. There are beacon modes that we can use, which are quite good fun. The one to look for is something called Whisper, WSPR, where basically you transmit a signal, and around the world there are receiver stations that pick up your signal, and you can see how far your signal's reached by transmitting a signal, leaving it a couple of minutes, looking online, and there'll be little dots in a map that show you where your signal's got to. So effectively you're putting out your own beacon and seeing who in the world can receive it. Very clever, WSPR as a mode. I won't read out your surname for data reasons, but AC, very kind donation, thank you AC. Let's give you a bit of your surname, CH. So ACH, thank you very much, sir, on the old smartwatch there. So hopefully that answers that one. Somebody asked, I don't think it was in the specifically in the request for the webinar, but where we're talking about our calling frequency of 145,500, which you'll see as FM calling, kind of there somewhere. Where else we can have a chat? And this is where you use the band plan. And normally what we would do is just notch it 1 or 2 up the frequency range. So 550, 575. So in multiples of 25 meg, so you click it once, twice, 3 times. Those 3 frequencies below it, or actually technically above it, are free for chat. And below it you've got 475, 450, 425, 400. So they're the common chat frequencies, and you literally make your contact on 144, 500. Sometimes you'll say go down 2, which would mean go to 450. Or you would literally just say go to 425. Then you put out your call, see if the frequency is in use, and so on. It will all come together and make sense when you get there, trust me. We're all baffled by it when we start, but when you start doing it, it all comes together. Right, what does necessary bandwidth mean in the table? So for foundation, you just need to be aware of that concept. And it's largely what we were talking about earlier. So Morse is very, very narrow because it's a tiny, just to hear a dot and a dash, you don't need much bandwidth. Data modes have a slightly smaller bandwidth. When you get down here at speech, the bandwidth is a bit bigger, and that's because to get, if we look at a channel, look at a slot, look at a frequency, whatever it is, you could get all your speech in there. With Morse, you could probably do it in that little tiny squiggle of a bit there. So you could get 1, 2, 3, 4 or 5 Morse transmissions in the space occupied by 1 voice transmission. So that just gives you guidance about the width of the signal needed for each part of that. You don't need to worry about that for foundation though. That is non-examinable. So that column there, you don't need to worry about for foundation. Bandwidth is covered in later modules. Later, it's intermediate and above. I hope that helps. Power lines love the house. Okay, what's bandwidth make? Whisper, yeah, Whisper's great. If you want to try it, go to pskreporter.com info/map.htm, I think. Double check, something like that, if not Google it. And that will show you where signals are at the moment. You can see propagation in real time, and you can filter it by country. So you could look at which country is, how to reach Australia, which countries can talk to Australia at the moment, what frequencies people are talking to Australia on, that kind of stuff. And that's all basically the same sort of beacon-y kind of concept. So have a look at pskreport.info. Brilliant at showing you where your data signals can reach. How does D-Star and stuff like that work? Are they really not cross-compatible? A bit. So we have 3 standards. This is for digital voice. So we all do analog, but you can go for digital. There are 3 formats. There's DMR, D-Star, and Fusion. And Fusion is also called C4FM. So they are the 3 standards. Those of you old enough to remember VHFs and Betamax, we're in the same turf here. So DMR is a kind of an open standard that any manufacturers could use. D-Star is ICOMS, and Yaesu, Fusion, and C4FM, again the rivals. So these are from rival companies. ICOM and Yaesu are the big boys, and they brought out their own digital standard, and they're not compatible with each other. DMR is not compatible with either of these either. So a good bit of advice is look at what you've got locally to you. If you've got a DMR repeater down the road, but you haven't got a D-Star repeater in your area, you probably want to be thinking about a D-Star, a DMR radio, and so on. They aren't cross-compatible. That said, there are certain radios and certain repeaters that can operate multi-mode. So locally we had a repeater around here that could transcribe between the two. So you could put in a signal DMR and get out a signal D-Star, and so on. Similarly, you can get things called hotspots for home, and they are multi-mode. They can switch between the modes. But if you've only got a D-Star radio and you're trying to talk to someone with a DMR radio, not going to happen. So irritating, but there you go. Any advice on choosing a first set? Oh, I knew I'd get that question. What radio do you recommend for those that have passed? Okay. The reason for my frustration is this is the question I hear all the time, and it is so difficult. Think of the question like this. I've just passed my driving test. What car should I buy? It's such a broad question. Do you want a sports car? Do you want a nippy little car? Do you want a 4-door or a 2-door? Do you want one that's with big boot space? Do you like red ones? Is it a family car? Do you want a brand new one or a second-hand one? It's so difficult to give an answer that absolutely everyone will go, great, everyone will buy that absolute first radio, because it really depends what you want to do. So broadly, you've got different categories. You've got handhelds, and you can buy a cheap one for a tenner. This happens to be a cheap one. It's actually quite a good one for a tenner. It's a Quansheng. It's quite a good getting started radio for a tenner. Or you could go for one like that. When I bought it new, it was about 150, and they both kind of look the same. Quality of that is amazingly superior to a 10 quid cheap and cheerful one. This has lasted me 10 years. I tend to get through these every couple of years. One drop and it smashes. That has been dropped and run over and all sorts of things. So you pay your money, you get what you buy for. These are analog. You could then buy a digital handheld. So that is my digital. So this, when I got it, was about 200, and it does analog and DMR. So that I bought because it's digital and I wanted to play with digital technology. So that's your handheld market. Then you've got your in-car market. Do you want VHF? Do you want UHF? Do you want digital? Do you want dual mode? Do you want it to act as a repeater? Do you want a discrete one that you can hide in a glove box? Or do you want a big full screen display? How much do you want to spend? Cheapest is about 50 quid. Most expensive is about 5,000. So take your pick. You've also got to think about how you install it and what type of antenna. You could have a mag mount on top of the roof, or you could properly mount it and drill holes, or you could have it on the boot flap. And then think about your power. maybe don't just buy one for your 10 watts at foundation. If you know you're going to go to intermediate or full, maybe consider a radio that's got a bit more power. Then you've got your home base. For that you need a power supply. You might obviously find that you need an AEMU, or you might not, depending on what you want to do. 12 volt power supply you'd commonly need. Then thinking about operating out in the field. So you would need a battery. Then do you want a lithium battery or a slab battery? So that's my portable battery, which is lithium. It's nice and small. I used to use a car battery before that. And then you think, do you want a radio that does all the frequencies in one box, or do you want a separate HF and a separate VHF UHF radio for different purposes? Then you've got the big, posh radios that it really is what do you want? And it's very difficult for me to say yes, you should all go out and buy a Yaesu whatever it is, because you might look at it and think, I can't afford it, or I won't fit in my room, or I want it in the car. It's very, very difficult, and it's not easy to give a simple answer to what everyone should buy. A common answer to that question is a lot of people start with a Baofeng, which used to be a 20 quid radio, maybe about 30 quid these days. Originally you could buy these sort of 150 quid ones. These came out at 30 quid and everyone just jumped on them because obviously it was massively cheaper. These are now being superseded by the Quanshings, which are a tenner. Now, 10 quid for a radio is bonkers, and actually they're quite clever customizable radios. You can flash different operating systems and things like that on them. So apologies, I really can't say yes. All 31 people watching this video at the moment definitely need to buy this particular maker radio, because it'd be like me recommending everybody buys a particular buys a Fiat. It's not going to work for everyone, but hopefully that gives you kind of a feel for the type of broad question that you're asking there, and maybe there's a couple of gems in there that's helped. Okay, hope that helps a bit. I know it's a cop-out answer, but I do like a cop-out answer every now and then. Bought one of those in a Baofeng. Would a handheld suffice rather than a desktop set? Again, what do you want? A handheld has a limit of 5 watts and a small antenna connector, normally a rubber duck antenna. So comparing a 5 watt radio with a little aerial like that to a 50 watt radio with a rooftop antenna, hopefully you can kind of see the difference. The higher the antenna, the better the quality of the antenna, the more power that you're putting out, the more you're going to do. So of the two, would you rather have a radio with a cheap aerial or a radio with 5 times the power and a much better antenna? Would it suffice? Yeah. Would it be as good? No. So, of the two, if all you can afford is a 10 quid radio, then it will suffice. If you've got a budget of 100 quid, you could get an antenna on the roof and 50 watts instead of an antenna in your hand at 5 watts. So everyone has a different budget, everyone has a different way of looking at things. So yeah, you can work with that, but you're not going to get that far. Better antenna, more power, you will get more distance, more contacts, possibly more enjoyment out of the hobby. So difficult to tell. Yes, Uzuma 2.2. I'm actually on 2.19, I think, on my Quanshing, but yeah, you're ahead of me there. Quanshing's are good fun. SXM website suggests the radio fully modifiable. Would that mean it's multi-mode? So it's analog. So that's this radio. It does do modifications. The modification will be so you can listen to HF on it. It's an analog radio, so no software is going to make that suddenly a digital radio for DMR or D-Star or anything like that. It's an analog radio. It's only going to be analog, but you can tweak it and get different frequencies, and it's sort of an experimenter's radio. Do the digital ones support cross-compatibility with analog? Some do, some don't. Depends on the make and model. The one I've got, this one is UHF only. It does analog and DMR UHF. Doesn't do VHF, so it's not hugely useful. But every radio is different. It's kind of like saying, do all cars do this? Some do, some don't. So if you're looking at a radio, think, is it multi-mode? Is it a mode that's useful to me? Does it have analog as a backup? Look at the specs of these things and take your pick. To be honest, we are sort of straying a little bit out of what you need to know for the foundation exam. If you are looking at buying a radio, the best thing you can do is get onto something like our forum, or get onto a Facebook group, or go to your local amateur radio club, talk to amateurs. It's the old joke that you speak to 5 amateurs and ask what the best radio is, you'll get 6 different answers. And also, finish the course, see what you want. Do you want to go down the data mode? Do you want to do Morse? You think you're going to go up to full, and maybe you want to buy a radio now that will see you right the way through your amateur radio career, 100 watts instead of a 5 watt radio. Talk to other amateurs, jump into the Facebook group. That's probably a big way of doing it, and saying, got a budget of 150 quid, want to work VHF in a car, what do you recommend? If you're really specific about what you want, people will give you an answer. Normally giving a budget is a good help as well. If you say I've got 500 quid for a handheld, they'll be recommending a multi-mode digital handheld for 500 quid. If you've only got a budget of a tenner, you're going to be recommended the Quansheng. So think about your budget, future-proofing to a certain extent, ask other amateurs and see what they recommend. Is there a way to make contacts from this session, e.g. forum? Yep, let me just ping you an address. So it depends. If you want to contact me direct, you've got a couple of options. Paul, I think you're in 160, aren't you? So in the classroom, you've got a discussions area where you can talk to the other 130 students on course 160. So you can have a discussion within the group of 160. There's also an inbox where you can email me privately. The email that you got with the link to tonight's webinar is me, so you can literally hit reply to that and it will come through to me. Or if you want to talk to the wider community, https://ham.uk/co.uk/help. So that address lists all of our forums, Twitter feeds, Facebook groups, trading community groups, Discord server. If any of you are in a Discord, we do have a Discord server. So that's all of our communities. Find the one that works best for you. Facebook and Discord seem to be the favourites at the moment, but you could just talk to members. We've got about 3,000 members across the world. Obviously great as well if you want to join up as a member of Essex Ham and talk to everybody else. But we've got quite a big community of people that you can chat to if you've got sort of general setup, budgetary questions, things like that. For the classroom, try and keep it to the exam syllabus only. I've had that before where people have been asking really quite detailed technical questions, and it can scare off other students who are just struggling to get the basics of Ohm's law, to see all this kind of, I bought this radio and what do I do and how do I do that? And so be aware that at the moment the classroom is mostly for new students, and they're not going to know the answers to detailed technical engineering questions that are not in the scope of the foundation syllabus, if that makes sense. When you pass, this is a good place to find second-hand radios. Yeah, that's fine. There's a few out there. We've got a buying and selling area on the website. There's a bunch of places. Some of the main dealers, Martin Lynch is one of the big dealers in the UK. They do trade-ins and second-hand stuff. Your local amateur radio clubs are a good source of that as well. Rallies is the other one, all the social rallies that happen around the UK. So clubs put on events where they buy and sell, so you can quite often pick up bargains there as well. Okay, so yeah, lots of Zoomers about. Yeah, there's a few of us about. So I think that was it. So we did beacons, we did repeaters. So I think we've done all the questions that I had in advance. I think I've done all the questions that you've asked me in the chat area. But let's see if there's any other questions. So anything else you want answers to? Section 4, open forum. Any questions on syllabus, exam, course, amateur radio, me, radios, anything you like. Now is your chance. Fire those questions away, and happy to help if I can. Oh, well, I rest my voice. Don't be shy. I am here for you. Any questions you've got. No question too silly. Just because you're seeing people asking all these really advanced questions. Don't worry if you've got a really daft Janet and John question. Don't be afraid. Ask now or ask me privately by email. Seriously, I am here to do my best to help. So fire those questions away while you've got me, or talk to me offline if you need to. That's also fine. You've all gone shy on me, haven't you? Where do I start trying with SDR? Okay, you want to get the basics. You'd be wanting to try websdr.org. So a web SDR is a web-based software-defined radio. So you basically use your internet browser, go to that address, and you can see a list of people that have set up their radios to be remote controlled. So there's one in Australia, for instance. Over the internet, you can connect him from the machine you're watching this on, connect to a radio in Australia, and tune it, and get it to change frequencies and see what's going on. So on that web page, there are loads of web SDRs all around the world that you can tune into. So if you want to listen with a web SDR, websdr.org is the best place to start. If you want to buy your own SDR, you can start with a budget one, like these little things. They're receive only, 15, 20, 25 quid off Amazon. They are not bad. It's a basic SDR for listening. They're not the world's greatest, but it's 10 quid. Then you've got the one I'm using. It's actually plugged in at the moment, so I can't unplug it. Can you see it? Just sitting there, plugged into a Raspberry Pi. Is a better one of these. So these are about 20 quid. That one's about 50 quid. And there's Hack RF, RF1 down the bottom end. SDR Play is a little bit more expensive. And then you're into the sort of 500 quid ones. But yeah, start with a 20 quid dongle if you want to just play around with them, or the web SDRs. Would I need an AMU? Depends what you're doing. So you haven't done the course yet, so you probably don't know why you need an AMU. So let's say, what's a good way of explaining this without you having done the course? So if I've got my transmitter here, and I've got a random antenna here. So what would happen if you put 10 watts into that antenna? If that antenna was absolutely perfect and designed for that frequency, so let's say 145 megahertz. If the antenna was perfectly designed, you put 10 watts into it, and all 10 watts goes out that way. Okay. If the antenna was set to the wrong frequency, so somebody earlier said, can we use a CB antenna for amateur radio? Yes, you can, but it's not going to be perfectly matched. And what you get when you put the 10 watts in, if there's a mismatch at your antenna point here, what happens is not all of the energy goes up it, some of it gets sent back the other way. And these are called standing waves. So if you put 10 watts in, you might find if the antenna is inefficient, maybe 4 watts comes back. So effectively only 6 watts is going out here, 4 watts is going back that way. If you now put 100 watts into that, 40 watts coming in will blow up the module in here called the power amplifier, and it goes bang. So you really don't want too much energy, certainly at higher powers, coming back from a poor antenna. So to prevent that, you would put an AMU in the way, and that will tune the antenna and match it so that you don't get that dangerous energy doing that and coming back into the radio. Most antennas for 2 meters and 70 sems, so the local stuff, when you buy an antenna, so that one, the 2 and 70, that is designed and built to be absolutely perfect on 2 meters and 70 sems. So I do not need an AMU for that. Similarly, I don't need an AMU for that because that antenna is perfectly built for the frequency. So it's more for HF where you've got a random length bit of wire or you're changing the frequency. So if your antenna is absolutely perfectly resonant, you don't need an AMU. Most of us don't have the luxury of so what have we got? 14 bands. So 14 antennas, 14 different antennas that are all absolutely perfectly matched. It's not possible for me to get that in my garden. So I have one antenna in the garden and an AMU, and I can use 14 bands with one antenna and an AMU. I'm hoping that kind of makes an element of sense. Thanks for Frequency Cast. Oh my God. Who's listened to Frequency Cast? Jeez. That's a podcast I did, a long time ago. So Drew Andy, do you know Kelly from Frequency Cast? Is now my buddy on amateur radio off the back of Frequency Cast. Oh my God, that's going back in time. That's how I met the lovely Kelly, who is my cohort on the training videos and stuff. Right, I was watching a DX Commander video on coax. He mentioned if it's too long, you can coil it to make a dirty choke. Yeah, yeah, to an extent you can. I wouldn't recommend it. You're best off having coax of the right length. But yeah, so a choke, again, out of scope for foundation, you don't need to know this. But if I had an antenna like that, potentially the coax can form part of the antenna system. What you normally have is something called a choke in here that just means, you know, that's the antenna part and that's the coax part. So you need some kind of choke, and a great way of making a choke is turning 7 or 8 coils of wire or using a block. So you can wrap it round there and it basically stops the coax forming part of the antenna. You can do it. If you've got a balun or an unun, that's academic. You're probably doing more harm than good because you're already choking it with the unun, and then you're choking it a second time with your coil. So it does depend on the situation that you've got there. My sound has gone. I'm going to drop out. Okay, cheers, Dave. Apologies. I think the sound looks all right at my end, so it must be something in the middle. You can always watch the video back if the sound's dropped. But thank you for watching. AMU would be regard to the cable thrown over the roof. Okay, have you got the concept of an AMU, or do you want me to run through that again? You probably see my answer to that, but did you want me to explain an AMU again, or are you good with that there, Paul? Can you fix 2 antennas and use a switch so only one coax into the house? Yeah, you can. Or would one interfere with the other? No, if you've got an isolation switch, yeah, you can do it. Not a particular problem with that. No, that's fine. Cool. So we've got the AMU one done. Anything else? Any other questions from anyone? Anything else? 29 people still watching. So well done for sticking with me on a Saturday night. Thank you very much. Will this video be available for a few days so I can get some of the sites? Yeah, absolutely. So the link that you use, just keep that link. This will be this will be up on YouTube. It's an unlisted one, so it doesn't appear on the main site. But if you've got the link, you can get to it, and they're not deleted. If you look in the classroom, at the bit at the top, there's the last 5 of these webinars in there. So you can watch another 5 of these if you're a real sadist. But yeah, there's 5 of them in there that you can just go back and watch if you want. So yeah, not deleting it. all of the ones of these we've done are all still online if you want them. Can you use upper and lower sidebands at the same time? That's a question I don't understand. Same time as what? Well, you might need to help me with that. So an AM signal has an upper and a lower sideband. So if you're using an upper and a lower sideband at the same time, and that's your signal, that is an AM signal. So that would be single sideband, SSB, SSB, and typically AM would be both sidebands. So if you're transmitting both sidebands at the same time, you're actually transmitting an AM signal. If that's what you meant. Sorry, one on lower AM. Some on lower AM. So I'm kind of struggling with that question. So that is the upper sideband. That is the lower sideband. So yeah, if you were using the lower sideband, it would look something like that. I'm not sure I've understood the question there, but if that's what you wanted, fine. If not, shout. I'm not entirely sure I understand the question there, but hope that's helped if that's what you were after. Thanks for taking the time to do this. The extranet repeater demo has been super helpful. Looking for starting the class tomorrow. Yeah, cool. Cheers, Joe. Thank you again. Thank you for the donation. Tomorrow morning, I'll ping you a link with some extra mock questions for that. That's much appreciated. Steve says thanks for the time tonight. Going to sign off now. Unfortunately, got to sign off early start in the morning. No worries. Union, thanks. I fully appreciate this. Thanks for taking part. Taking out some buzz in. Great hobby. It's a real good fun hobby. And I do this because I got a kick out of this hobby when I started it 12 years ago. And this is me giving back stuff. So I love doing these because I was like some of you 12 years ago. It was all new. This sort of thing didn't exist. And I wanted it. I was at home going, I need to ask questions, I need to understand, I want to look stuff up. That's how the concept of SXM came about. And I'm imagining 26 people just like me wanting to know answers to stuff or struggling with a topic or wanting just to talk and get stuff out there. So that's kind of what these things are all about. Okay. Drew, Andy, cheers. Enjoyed these. Thanks for that. John, thank you. So, no other questions then? Nothing else? Any final thoughts? Any silly questions? Anything suddenly jumped into your mind and you think, oh, I wish I'd asked about? I'm quite happy to hang on for a little bit longer if anyone has anything else. Any topic you like. And if not, I'll let you all go about your the rest of your weekend. For those that are starting the course with me tomorrow, normally about 3 o'clock, Module 1 gets released, only because I'm still waiting for people to sign up. There's about 40 that haven't signed up yet, so I'm leaving it until about 3 o'clock tomorrow as the cut-off time to get as many people onto the course as I can. And then you'll get a new Module 1 tomorrow, Module 2 Tuesday, Module 3 Thursday, a quiz, how are you getting on quiz on the Friday. If you haven't as well already, those starting tomorrow, there's a sort of a warm-up quiz. Oh, hello, cats come in. Anyone like cats? Any cat fans on here tonight? Want to meet the Shack cat? Yeah, there's a warm-up quiz. Give that a go. If you get all the answers wrong, it doesn't matter. It's just kind of getting used to multiple choice questions. Yeah, try that little warm-up quiz if you can. Thanks, Emil. Sideband questions in regard to radio settings. Conshung has FM, AM, sideband, upper and lower. Okay, so hang on. Anyone with the cat? Always, as an always. Hang on. Come and be social. Come and talk to some radio amateurs. Look, oh look, little Teddy. Ted at Shack Cat. Food time, so he's coming in for a hug. Oh look. Right, there you go. Thank you. Upper and lower sideband. So we have a rule that you will probably have come across in module 3. So we use lower sideband is used on frequencies below 10 megahertz, and upper sideband is used on frequencies above 10 megahertz. It's kind of a historical thing. So if you're on the lower frequencies, we always use lower sideband for historical reasons, and upper for 10. So on, I don't know, on a frequency of 14 megahertz, most people will operate upper sideband, and it's consistency. So you know that you're all upper. Potentially, you could have some people on upper and some people on lower. If you had the stupid situation that on one frequency, one person was doing that and another person was doing that, it would just about work. If that was upper and that was upper, that would kind of work. But if you had on that same frequency one person using upper and one person using lower, then they're going to kind of cancel each other out. So you want, you could have a lower there, that would be fine. But upper and lower at exactly the same frequency, one radio tuned to upper, one tuned to lower, they're just going to overwrite each other and cancel each other out. So for consistency, over 10 megahertz, everyone uses upper, so everyone can hear everybody else. But yeah, one person transmitting upper, one person transmitting lower will interfere with each other. Same as one person transmitting AM while one person's transmitting FM on the same frequency will upset everyone. Same as someone using analog on a frequency and someone else using digital on a frequency. They're not going to hear each other, they're going to be wiping each other out. So that's why we try and be consistent and all use the right frequencies in the right place. That's what you were trying to say. Hope I've answered that. I wasn't clear where you were going with that one, Andy, but hopefully that's got that one. If not, shout, because that I appreciate that's an odd one. Separate TX cat picture. I've got a Norman Studio cat. Android devices have UK. Yeah, be careful of some of the apps and some of the websites out there. Whatever you do, avoid a website called Radio Tutor that offer free mocks and free exams, because they are. There's a major syllabus change in 2019, and that's an old site that's on the old syllabus. The syllabus changed by about 30%. I've seen people do it. They use Radio Tutor for all their mocks, and they fail because the mocks aren't right. Basically, the syllabus changed. Radio Tutor's not being maintained anymore. There are some websites out there that have mocks that aren't accurate. There is one app that's not as good as the others. I know the guy that runs it, so I'm not going to be critical or anything, but just get your mocks from a decent source. Similarly, there's a few books out there that have mocks in. Some are better than others. This one's a good one, but don't use the old. So there's an updated version. The syllabus does change every year or so, so don't rely on a book that's got the wrong age of questions, and get them from a decent source. So RSGB have 2 free ones on their website. There's a book called Ham Secrets, which has loads of mocks in. That's generally quite good. But again, there are out-of-date versions out there. We offer mocks, so those kind enough to make a donation get a bunch of mocks from us. Books, websites. Some of the apps are good, some are better than others for mock questions. So shop around, but just be careful on some of the older ones. What you want to be looking for is syllabus 22, not syllabus 19. In September, you want syllabus 24. So just be a bit wary of what you get there for mocks. Right, I think we're all good. If there's nothing else, I will wrap it up. The number of viewers has dropped quite a bit now, so I'm guessing people are switching off. But thank you for your time. Final questions, last chance, and then I'll let everyone go. No worries. Cheers, Andy. Nessimon, thank you very much. John, ta-ta for now. Shack Cat's kicking around somewhere because it's food time. It's been great. Cheers, Joe. Enjoy the course. We tend to do these every couple of weeks, so those starting tomorrow, we'll have another one of these maybe 2-3 weeks' time, by which time you know what we're talking about. Cheers and good night. Yep, cheers, Union. Thank you very much. No more questions by the looks of it. Hey, I'm a star. Lovely. Thanks, Alex. Cracking. We'll enjoy. If there's nothing else, I will wrap it up. Thank you again for your time tonight. Good luck for those sitting exams. If you've got any questions, shout. I'm really here to help and get you to pass. So just shout if you need anything. Otherwise, good luck. See you in the classroom. And have a good rest of the weekend. Cheers for now, everyone. I will press the magic button and say goodbye. See you later, folks. Ta-ra.